Ja, hallo, goedenavond, good evening, buonasera, that's about all that I know in that language. So thanks for being here. I'm Geert Bevin and I'm going to talk about gesture control. So, I am a product manager at ZeroTurnaround working on the RebelLabs product, and this talk has got absolutely nothing to do with our company, but they're still so kind to let me speak here. So do check out our products, they're quite amazing. So I've been a Java champion for quite a long time, and I've been part of a whole bunch of open source projects and products and frameworks and libraries for the past years, decades. What qualifies me as someone that is going to speak about gesture control? So I kind of picked up the Leap motion controller even before it came out. I was one of those developers that got them as the first batch was sent out. And I worked very closely with them to get apps into the store at the launch of the Leap motion controller. So this is a Leap motion controller if you haven't seen it before. It's a tiny little device, and I'll detail some more about it later. And so I got 2 apps in their store almost right at launch time of the device a year ago that became the most popular apps in their category. So one app that allows you to control the computer but was designed to play games with, it's called GameWave. Another one to make music, which is called Gecko. And then when I created the 3rd app, which is a free app that very simply allows you to control the computer, and that kind of resulted in about 40,000 users with various inputs and reactions from those people. So I have a little idea about what works and what doesn't work when you're doing gesture control. I've had the Untitled Myo armband for quite a long time also. I had the alpha version and now the final versions. I'm working on some software for that too, but that is still like a little bit in the future. So this is the Leap motion controller that you see down here. Is a little device. You can see it on the screen. And what it does, it basically measures the position of your hand and your hands and your fingers in 3D space. So let me show you a little demo of what that looks like. So you can see here at the top, you've got a little icon that shows that the Leap motion controller is connected. So if I launch the visualizer, that is actually what you can use to see if this device is connected. And as I put my hand above it, you can see that it detects it, and I can kind of play around with it, bring in a second hand, do kind of crossing my finger, say, hey, this is great, yeah, rock out and stuff like that. You can cross around. This is kind of new that you can do this thing. Sometimes it works, sometimes it doesn't, but it's much better than before. The challenge is the lights here are kind of interfering quite a lot, but it's still tracking very, very precisely. So as you're in that visualizer, there are a few things that you can turn on. For example, let me just turn it on in the preferences first. And this is quite new, and I wanted to show this. They're exposing, for developers, the actual imagery that is being shown. Oh, I should probably say OK. Right. So the actual imagery that it's seeing. So you can see that it's just 2 cameras, and they're using the stereographic view of field of view to apply some math equations, a lot of math equations to that, to model into hands and positions in 3D space. So that's quite impressive, I think, that they're able to just work with those two images and get such precise information out of there. So let's do a technical overview of what you can do with the Leap motion controller. So technically it is typical Cartesian coordinate space. You've got about 60 centimeters of height where you can interact with it, and it's got this slanted shape to the sides where it will not see here, which is kind of logical because the cameras cannot see straight here, right? So they will have this angle. You have to know that when you're developing the apps. So when people are going to come closer to the device with their hands and they're outside of this angle, you might not get any recognition. And so Z is towards you, which to me was a little bit weird when I started working with it. I kind of expected it to be away from me, but still. So Y upwards, X to the right, nothing special here. And what you get is tracking data that's being sent to you at the speed at which that it's able to do the detection of your hand movements. So each time that the frame is detected with stable information, you get all this information. You get the hands, the fingers, the bones inside your fingers, the gestures that you've done. If you're working with tools, the tools that you're interacting with, because it can, for example, detect that you're holding a pen or a thicker pen or a smaller pen. So you can, for example, attach different behaviors to that. And then the images that I just shown. And the thing is that each of those has a unique identity. And why? It's because you get individual frames every time that the information is available. There is no session or anything like that. So you have to be aware of which IDs are being continuous in time and rely on those to actually attach behavior to that. So these are the languages that support it. It's quite a bunch, quite a few from the community afterwards also. I've done a lot with C++ with this and also a little bit with Java. And let's show later what you can do with Java and the Leap Motion controller. So how do you get, and I really like this architecture that they came up with. So the problem that they had is, how do you allow people to build native apps and also web apps with a single device that is connected over USB and then being able to connect all these services at the same time? And so they've got a Leap service widget running, which is a background application that allows you to get the information straight to the language bindings that are supported. But at the same time, and I really like that, is they have a WebSocket server that actually publishes all that information over JSON. And that is, I suspect, also what the native language bindings use. So they all just get that information over a local socket, meaning that any application can actually consume this data and work with it. It is not like a one-to-one connection, which is quite nice, I think. So let's look at a basic example of how you'd use that. So in Java, it's really simple. You've got highlighted the lines here that are kind of interesting for the Leap Motion controller. So you create a listener that will get callbacks, and then you instantiate a controller. You basically add a listener there, and when you're finished, you remove the listener. And then you get a callback interface on that listener, and on each interesting event, it will just basically call you back. So when it initializes, when it disconnects, you also know, so if you disconnect the Leap Motion controller, it will typically show the users like, hey, you've disconnected it, I cannot do anything anymore in my application. And then the two most interesting methods here are the Unconnect method, where you start setting up everything that you're interested in. In this case, you're interested in swipe gestures. And then every time a frame of information is available, it will come back on the onFrame method. And then it's just up to you to query that amount of information that is available in the frame and to do something with it. So getting that to run is quite easy. Basically just compile it with the jar in the class path, and let's see if I can show a little demo of that. So this is now just printing out each frame ID, and as I put my hand in the picture, it should show a hand that has 5 fingers, right? This is actually kind of new, because in version 1.0 of the API, you could have a hand with 1 finger. But now that's not the case anymore, because they correlate the data that they get from the images to the actual skeletal model of your hands, and they know that most humans have 5 fingers. So 2 hands, 10 fingers, and then when I start doing gestures, you can see that I've got the swipe gestures are being registered, so I'm just printing out the counts. But it's extremely fast, right? If I just do 1 swipe, you can see that it's almost impossible to see it pass by. It's normally running at about 200 frames per second if there is no light interference. So here there is quite a lot of interference, so it will slow down. It will probably be around 80 or 100, maybe 120 frames per second, which is still quite a lot of information. So getting that to work with Java is easy. And let's now show a little demo of one of the apps that I wrote and what you could, for example, do with it. So this app is called GameWave. It's an application that allows you to map specific gestures with 2 hands to operations that go on your desktop. So I can go in, I can bring in my hands, and I can make a a tab gesture and then start moving the mouse around. And I can see that there is really a lot of interference because normally the mouse is quite stable, which is not the case here. And so I can drag stuff around. I can switch between desktops, for example, which is quite handy. I can turn the volume up or turn the volume down or start some music playing if it registers the... Oh, there you go. So it's starting some music to play. Right. So that works quite well. What I personally also use here quite a lot, and that is just put my hand here and start scrolling up and down. So if you're visiting web pages, I find this quite easy. And then if I stab, then it closes the window that is in front. So this is stuff that you can all set up with the GameWave application. Oh, and it seems that it's added a slide here. So it can even write your slides for you. So wow, that's actually a perfect application for any conference. So this is a demo of people actually using GameWave of what it was intended to, playing games with. So this is someone playing Skyrim with it. So he basically just has the lead motion controller down at the television. And I really like this video because Skyrim shows your hands on the screen and he's got his hands in the same video, and it feels as if you're really there. And so people are using that with a variety of games, sometimes just combining it with a keyboard to do very specific commands at like shooting or throwing a bomb, and mostly doing navigation or actions like in MMOs with GameWave then. And you can see that the control is really quite good. He's even hitting him on the head and talking to him. So, that's a short demo of that. So the reason why I'm showing these videos is one of the reactions I get a lot when I'm talking about gesture control or showing these devices to people is, yeah, but what can you do with it? This is interesting, but has it got any use? So I will show some other examples throughout this presentation to show that you can actually use it for a lot of things. So gaming is here a first example. So which data models do you have access to? So I kind of hinted towards that already. So it all starts from a frame that gets the information as the callback happens. And then you basically have lists of information. So you have lists of images that I've personally never used because it's quite new. Lists of the hands and lists of the gestures. And inside the hands, you obviously have hands. And then your arm is attached to the hand, and your fingers to the hand. And then each finger has bones. And a hand can also have tools. And both fingers and tools are pointables. And the pointable is basically a vector in 3D space that has a direction. It can have a length and a thickness. So that's kind of what fingers and tools have in common. And then they support a bunch of gestures. I'll detail these a little bit later. These are not open, so you have to kind of go with the gestures that they have. They don't have a learnable interface or a learnable API where you can craft your own gestures, but that doesn't mean that they're not possible. Like for example, in GameWave, in this app, one of the gestures I created is when you put your hand in the app and I double tap with both with my hand open, it creates a gesture. That's like a very distinct gesture that always works. The problem though is when you're designing gestures is how do you make gestures that have no false positives? That's kind of the weird, the most horrible thing that can happen is that you're doing something and something unintended is happening. So that's why they only limit it to these gestures that are provided because they know that they work really well. But if you spend the time to come up with your own gestures, it's basically just a state machine, right? You go through different stages of recognition and see if you hit the different stages that you want, and then at the end you detected a gesture. So each frame has for you some particular properties that you can directly query. You can see what the axis of rotation is, meaning that the whole movement compared to the previous frame, is it going to be a rotation? Which angle is it going to be? If you want to do use transformation matrices, those will be there also. If you, for example, make smaller, if you've got a smaller field that you're using with your hands and you're going to be expanding it, it's going to be detecting that the global kind of distance used by the interactions are going to be bigger or smaller, and then provide you with a scale factor, and then also if you're going to translate it from one side or the other. And this is on a frame level, so it is for everything that is in the frame. I've personally never used that. But then what you get one level down is inside the list of hands, you've got your hand, and in the middle of the palm of your hand, you've got a vector that is pointing forwards and a vector that is pointing down. And so the vector pointing forwards is the direction, and then the vector pointing down is the normal, and then it also allows you to have the position compared to the actual center point of the lead motion device of the center of your hand, and then at which speed that it moves through space. And so with these pieces of information you can do a lot. So I modeled quite a few gestures just based on that, because it's a very stable reference point, the middle of your hand. People can keep that quite steady. It is something that you can keep under control. While fingers, after a while, start shaking a little bit, and it's very difficult to constantly start pointing with one finger. So I prefer working more with hands and only punctually with the fingers. So some other things that they added is grabbing with your hands. That's like in version 2.0 of the API, so that you can grab and it will give you the amount of strength, so the closeness of your hand and how much you're pinching. So these are two new things, which allow quite a few new interactions. I still have to adapt my software for that, but the idea is that you can easily have a pickup motion and then move it around and let it go, or grab motion and turn it. So these are interactions that are now working very well. And then there's another set of attributes here that I don't particularly recommend that you use, but I'm just trying to be complete. So they allow you to have a sphere, like a virtual sphere at the bottom of your hand, which is very flaky because it relies on the curvature of the palm of a person, I guess. Well, that's my theory about it, because I could never get it to do anything really predictable. I don't know if anyone else was able to. I can see Claude laughing there, so I think she's in the same situation as me. It's quite funny to, well, I think that was their first attempt to do a grab approximation. So they would have something that allowed you to grab, and then they went to version 2.0 of the software and realized that they had to have that skeletal model to be able to do this properly. And now you can see that, so I talked about which properties that you've got available for each frame. They have exactly the same properties for each hand. And now this is starting to become useful to me, is you can very easily rely on the axis of rotation of a hand and see that that's one number constantly streamed to you and connect something to that. The same thing about the movement of your hand. You've got that immediately available. And then you've got these lists of things that are attached to your hands, so which are pointables, fingers, or tools. And already kind of hinted to what they were. Again, they're vectors pointing out, they're attached to your hand, they've got a length, a width, a direction, a position of the tip, and then also a speed and the velocity. And then the bone model is something they just added. I've not used it, but it's quite impressive looking from the API that you're actually, and you can see it from that tracking demo that I gave, that it's actually able to see all the individual articulations of your fingers. And I'm kind of blown away that they're able to do that with just 2 images, and being able to detect that kind of information just based on that. So let's go to another example. So I showed gaming as one concrete example of what you can do with gesture control. And I had this video sent to me by someone, well, by a surgeon, and they're actually using GameWave, which is a gaming app that you just saw someone slashing someone's head with in Skyrim. And here they're using it to do an operation. So it's kind of ironic. And so The nice thing here, though, is, and I didn't realize that, a lot of surgeons, when they have to do an operation, they have to consult a medical imagery outside of the operation room. They have their computer outside because they have to touch the mouse, and the mouse is not sterile. So they cannot touch a mouse and continue operating. So if they forget something, they have to stop operating. You might be open and the clamps are like pulling you apart, right? Oh, what was that again? So they have to go out, they have to go to the next room, look at the imagery, scrub their hands, dry them off, put the gloves back on, and then come back in, which is not very ideal. So what they're able to do now, since they've got this Leap motion controller that is never touched, they can just keep it sterile in the operating room and go one step further. They don't even have to remember everything about the 3D imagery. They can consult it whenever they need it. So it gives them much more confidence whenever they're doing their operations because they can navigate through these 3D images. So, which gestures are supported by the Leap motion controller? That's the first one, just doing a circle with your finger, or all your fingers, so if you're doing this, right? So it will provide you with circle gesture information for each finger that it sees doing that, which is much more difficult than you'd anticipate, because they might not be starting at the same time. It might first see one finger and give you a first circle that is started, and then only a second finger enters the field of view, and then a second second circle gesture is starting, and so on. So if you, for example, have to have a gesture that responds to, I'm making a circle with 3 fingers, you have to compensate for the fact that it could kind of gradually build up and gradually build down. So that's why I said, if you get the frame information in, you've got unique identifiers for each element there, and you will have to keep track of that. That's kind of a downside. You basically end up building a whole bunch of state machines. So you've got the swipe gesture, key tap gesture, which is frankly kind of horrible. I've never got this to work really well, and I don't like doing it either. You want to tap something, and screen tap is even worse. That feels like poking someone's eye out. Well, this sometimes works, but this is... So, I gave you an example of a Java app. Let's do another example, just showing another way of using it through the WebSocket interface with JavaScript. And this is kind of nice because if you have a Leap motion controller and you visit their website, they actually provide you with interactive examples of what you can do with the Leap motion controller. So since they can just provide you with an HTML file that will connect to your local socket and get that information streamed to the web page that you got remotely, it actually allows you to interact with the web page with gestures, which is quite nice. And you can see a whole bunch of demos there that are quite impressive. I think they even use OpenGL in there with 3D representations. So I was quite surprised of seeing that. So let's quickly show that so that you can see that it works. Where is that? Should have opened that before. Dropbox. There you go. So this is kind of the same demo as with the Java one. When my hand enters the field of view, it still has 5 fingers. And then when I'm making gestures, it's basically showing them. So easy stuff. So another showcase, an example of what you can do with gesture control. And these are all just ideas to spike your imagination. Because I was surprised that, for example, this surgeon use case, I never thought of it, but people picked it up because they were enabled by an application. So Gecko is an application that I wrote that allows you to basically manipulate sounds and play music with your hands. And so this is a a short kind of collage of people that did things with Gecko. So here what you have is a composer that is playing with his right hand on the piano. Yeah, it is like the marketing video, so that's why you've got these words coming up in the beginning. But with his left hand, he's giving all the dynamics. And this is a beatboxer that is, while he's making sound with his mouth, he's modulating it in real time. And so what was interesting, that beatboxer sent me this video only 1 week after the first release of the app. And I thought that was amazing because he really created a live set immediately with gestures. So there is a whole audience out there that is waiting for gesture-based control and that is sparked by that enablement. There's someone playing the clarinet. So he's playing the notes with the piano again, and then modulating them with his hands. Oh, sorry. And the next guy, he's doing everything with the Leap Motion controller. So he's basically triggering loops and modulating them in real time with both of his hands. And this is a Russian artist that is, he's doing quite well. He's using it live, and this is one of his promo videos. He's basically performing for himself in the train. So he just has Gecko on his lap together with a grid controller, and he's kind of doing stuff. It's a fun video if you watch it completely. So another application that is quite recent is that Leap Motion created a mount to actually attach the Leap Motion controller on the Oculus headset. I have not tried it yet, but you can see some demos that are quite impressive, and I've got a video of that also. And so to be able to do that, if you ever want to start working with this, you have to, or try it out, you actually have to say that it has to, let's see, oops, go to a different tracking mode. Where is it now? Huh. I guess that they're doing it automatically now. So they must do it with auto-orient tracking now. In the previous, I just did an update. Never do an update before you do a demo. So in the previous version, they used to have a little checkbox saying, okay, the imagery is actually coming from the top and not from the bottom, right? Because, and it's also vertical instead of horizontal. But it seems that they were able now to do that automatically based on the information that they get from the calculations. And this is an example of a guy using that. So he basically built his own 3D interface using the Oculus to navigate around, and then as his hands move into the field of vision, since you've got that skeletal model, it is perfectly following the movements of his fingers. And here again, the center of his hand allows him to interact with objects, so things stick to it, and as he taps it, he can kind of operate. And this is one of the other use cases. If you go to the App Store of the Leap Motion controller, there are a few apps that are quite interesting because they're geared towards education, where people can kind of explore the human body or explore biology or explore how animals are built, basically. So this explorational aspect of gesture control is quite powerful. So it's quite amazing that this guy built basically a whole user interface, and very quickly also. He's just ripping that guy apart. There's a common theme here, right? Like in Skyrim, like slashing heads in, and then surgeons like cutting people open, and he's dissecting a skeleton. I don't know. So that's that for the Leap Motion controller. So my opinion is that if you want to get started with gesture control, I think the Leap Motion controller is the best device out there for a few reasons. In that it is kind of mature. It has been out there for more than a year, and they got, all the growing pains are over. They got to version 2 of their software. They learned from their mistakes. They have some very nice properties, which are that they're cheap. I think it's about $80 for a Leap Motion controller. Also, they're connected with a wired connection. A lot of people I hear saying, yeah, but it's not as cool as the Myo, because this is the Myo. It's wireless and you can walk around with it. But that is kind of scares me here, because it kind of works one time out of 2. I don't know, it's probably the interference, or if a lot of other Bluetooth devices are there, or I don't know, maybe I've never had this kind of flakiness with the Leap Motion controller, since it's a wired connection. And the other advantage is that you get a shitload of information. It can stream very fast. It is a wire, and that is why you can make all these subtle movements and really have this precise control, and it's able to send that for all your fingers and your hands. It supports up to 4 hands, so you can theoretically even build applications where people collaborate, and those 4 hands together do something in virtual space. So this is the Myo. The Myo does something quite unique, though, in that on the inside you'll see it's got these metal contacts, and these touch your skin and will measure the electrical activity inside your arm, basically. And so what does it have? It is wireless over Bluetooth LE, which is surprisingly work with most modern portable devices, but most laptops not. So you have this little Bluetooth dongle that you have to put into your laptop before it works. And then it supports vibration, so it can alert you when something goes on. I'm also a little bit on the fence about that, because often I don't notice it. Because you're busy doing something, and yes, there's like a little vibration, but it's not hard enough. So maybe they should stab you or something. Because it is okay, but often I'm like, oh yeah, I forgot. It alerted me. And then, yeah, status LED. And for the rest, it's actually quite similar, because we're talking about gestures. So you get a data stream of information again. In this case, it is the orientation of the device on your arm, the acceleration, so how fast are you moving, and then the gyroscopic information. And it supports only 5 poses. Those are not gestures, those are poses. So it means that you have your hand going to the inside, to the outside, spreading your fingers, making a fist, and then something very weird, this. And then thumb to pinky. Now, try it. I've seen quite a few people imagine doing that. It's not that intuitive. But I guess that they had to come up with very discrete different poses, because the electrical data from your muscles has got a lot of noise in there. It has to, just the fact that you're moving, something might be rubbing against your skin at the same time. And even at this point in time, I don't consider the poses particularly stable. So what happened was, when the alpha versions of the Myo came out, I was actually blown away. And the reason was that they had a training program that you had to run each time before you used it. So you just went through the motions, and they were always afterwards, let's say 95% correctly detected. But now, since it's gone to mass production, I understand that they wanted to get rid of that training. Each time you put it on, let's train. It's like not very useful. But the downside is that it seems to work well on some people, and other people it's still kind of very flaky, like for me. I guess I'm one of the unlucky guys. So if you do have a Myo, what you have to do is there's a little checkbox that you click where you send them your gesture information, and they will collect, and that's kind of the thing that now I think needs to happen. They need to have this time to mature, which Leap Motion Controller has had for a year. They found the deficiencies of their device, have ironed out the kinks in the cable, and now it's really useful. For Myo, they're still like in the beginning, and I think maybe like in 6 months' time, they will have gathered enough information from the masses to change and adapt their models so that the poses are more stable. But please don't say, okay, it's not, I've got a Myo, it's not working, I'm not using it. Try once in a while doing that so that they get that information, right? So that they can build their models. So the architecture is almost identical. You've got a hub to which you can connect multiple. Well, that's kind of nice. They support multiple instances of the Myo. So you could have one on each arm, on each leg even. But you cannot do the poses with your leg, but you could kind of shake them in space. I can see some dance applications or something like that. That would be kind of fun. So they allow you to connect multiple Myo instances, and then you've got a listener interface, and the language bindings are also still quite young. You can use Java, but only when it's running on an Android device. Okay. C++, Objective-C, and otherwise they've got a scripting language, Lua, that works directly with their Myo Connect kind of hub application. And this is a piece of code to just show you that it's quite similar. You've got a listener that again gets callbacks, and when you get orientation data, you use it. You're much closer connected to math though with the Myo. They instantly whack you around the head with quaternions. I have no idea what they are, and I tried to learn it, and I read, I don't know, 5 pages of something that's now a blur, but it is something mathematical in 3D space used by 3D apps. I don't know, but so you have to deal with that. And then when a pose happens, basically you get a callback also. And so it's quite easy to work with. You have different methods also to connect a Myo. Either it will automatically connect to the one that is closest, or you can explicitly connect it, show a dialog and say, okay, these are all the Myos that are in the vicinity. Which one do I want to connect with? And now I'm gonna because I've got a bit of time, see if it works. I'm going to unplug the cable, is that okay? So I've got this prototype app that has worked 50% of the time, which is really not that much to try to do in a demo, but let's give it a try anyway. So, so they removed the training, but they added something else, which is a gesture that allows they call it a sync gesture, but it does look quite stupid though. So you have to hold your hand out, and then you do this, and then you wave out, and then it doesn't work. And yeah, so now it worked. It gave me a little notification, and on my iPad it shows me that it is on my right arm. And let me see if it seems to be not that bad this time. Let me see how I can get a music app going. So what I did was I basically wrote a gateway app that transforms my gestures. I have to do a little calibration here. That transforms my gestures into musical interactions. So I can you turn on the sound? Yeah. So I can basically sculpt sounds, right? Or pick another note. And stop it when I'm making a fist. I've tried to get this to work for the whole day, and this is the first time that it does it without any. So that's quite. So yeah, that's kind of the downside, right? The false positives. Let me take that off now. So I'm gonna unplug it again, okay? But if it works, it is fun, and I think it just takes time. So they just need some time to have this mature, get some more statistical data so that they can build better models. When they had the training in place, I actually did a performance with that prototype application because it was very reliable. And I did a musical performance and I could sculpt sound in real time and pick my notes. And so I think there is a very good use case there. One of the nice things that you already can do now, if it detects your poses correctly, is immediately interact with Keynote or with PowerPoint, advance and go back with your slides, turn on music, turn it off. And there are some people using it with mobile devices, like you've got your phone in your pocket, you've got the Myo armband on. It is kind of thin enough, I guess, to wear constantly. The prototype version was kind of twice the thickness. So you could wear this while you're on the street, and then you can just walk like this and do that. Right? Well, no one will notice. But it is, I think it is, we might go into a time like that, right? Does anyone remember when cell phones appeared? I felt so strange, like, oh, I got this thing against mine. So now we're going to have people. So, some personal findings about working with this stuff. So, these are all just my points of view about working with these things and seeing the apps that haven't gotten much uptake and then trying to figure out why some of the things that I did worked and others didn't. I'm personally convinced that people like feeling in control. And being able to feel in control requires that the tiny little changes that happen in your movements, you have to be able to see them reflected somehow. You have to feel that it has an impact, even if it lets you make mistakes. So my approach is to only very rarely filter and to give that as an additional option and not do it by default. Some people might need it. You have to be aware of people that might have trouble staying steady, or there might be a situation where the environment is not suitable so that there is a lot of noise and you might want to start adding some smoothing curves. But in general, I think it's better to just allow people to learn how to interact with your application, right? So that they can feel in control. Second step is actually goes back to the Myo, is avoid machine learning. It takes such a large data set before you get something that is usable, and then you need to tweak it for so long. And I've seen apps that never get it right. So what I basically do is I try it out myself for a long time, and then I give it to everyone I encounter. Like, can you please try this out? And I watch them interact with them. And to me, that also gives me a lot of valuable information about things that might not be clear. So I much prefer coming up with distinct interaction models that work well and that I've tried with users than to try to mathematically come up with a perfect solution, which in general I've not seen working that well. So the third point kind of goes to what I said in the beginning. Allow people to actually learn your applications, to feel in control, and to have a UI that makes them comfortable and say, okay, I did this, yes, it's working, right? And not, okay, I'm moving my hand, it is moving, I'm gonna get there, because there's some apps that filter so much that you feel this delay and say, okay, it's not good enough. But it's just because they try to avoid people making mistakes. And so yeah, I don't, we're all used to the mouse now, but I think that a lot of people, sometimes you see people that have not used the mouse a lot, they can do a lot of weird things. It can, or someone that uses your computer. I have this all the time. Like, I've got this thing set up to the left, right, in Mac, where to my corners it uses Expose. Every person that uses my computer and that touches the touchpad does this. I say, what? You have to learn to interact with things, but that's not the reason why you should shut everything down. People just have to, it takes a little while. So another point is to very carefully pick your gestures. So it is nice to come up with complex stuff, things that, wow, this feels like Minority Report. By the way, has anyone seen Minority Report recently? No? Well, I did the test and I watched it again, because there is one thing is the memory of Minority Report, and then there's the reality. And the reality is this. It is not, right? This is what people remember, is he's like waving his hands and it's doing a whole bunch of cool stuff. That's not what he's doing. He's making very specific gestures and controlling them in a very, deterministic fashion. And that is what you have to learn. You have to learn how to interact with the new model. And picking gestures that are complex will take people time to learn it. And not only that, they don't necessarily use your application all the time. It would be like a traditional mouse would do something different for each application. That would be kind of confusing. So people want to have some consistency. So if you come up with some new gestures, try to limit them, because otherwise people will be frustrated. Another point, and that is kind of one of my pet peeves, is consider people that don't use the screen. So we're also used to the model where we have a mouse pointer that moves in 2D space and that interacts with widgets and windows and buttons, and that has an inherent relationship between the two-dimensional representation and the location on the screen. So you always look at the screen. And it's very tempting to create a three-dimensional application or interface that you control with a three-dimensional model that maps on a 2D screen. The problem with that, in my opinion, is that you'll always be doing like, okay, where am I? What am I doing? First of all, because you have no 3D. It is a two-dimensional screen. And secondly, because you don't feel enabled. Your hand-eye coordination is much slower than if you would enable people with other cues. For example, audio cues, or vibration, or basically just whatever is going on, allow them to feel in control without constantly giving them positive reinforcement on the screen in 2D space, because that will get them glued to the screen instead of feeling comfortable with themselves. To me, that is what kind of the promise is of gesture control, is that you're building your own environment in the real world. We as programmers are able to get that information and do something virtual with it, but if you don't let them feel comfortable without being glued to that screen, I think it will always feel artificial. So it's a good thing to keep in mind. How can you make something that doesn't require this hand-eye coordination confirmation all the time? And so that's another point here, is about latency. So if you work with the Leap motion controller, I hinted at this before, it is a shitload of information. It is 200 frames per second, I think sometimes even 240, going down to 120, it's still a lot. If you're doing that in Java, you will notice it. It will be a huge memory churn, and it will try to keep up. So you have to take that into account. And in my opinion, the solution is not to filter out data and to remove that amount of data. No, it's to build your application in a way so that it can cope with it, so that each small interaction, each tiny little piece of chaos becomes part of the interaction model. And that, in my opinion, is what makes it magical. It's when people don't understand exactly what is going on, but even the smallest interaction will start to feel natural and becomes magical. So consider latency. You might want to build some kind of a CEDA architecture, but in the client side, where you've got multiple queues that hand off stuff to each other to get away from the callback thread as quickly as possible, to only pass things around whenever you need it. And then to test in suboptimal environments, that's also part of the latency. If you don't do that, you can get very bad results. These are some other things. I'll just read them off the screen. So you have to be aware of the battery and CPU usage. This is something that I've been guilty of. I just realized after that Apple brought out the bastards. Since Mavericks, they've got the how do you call this again? You get activity monitor. There you go. The activity monitor now has energy bastards. So now you can see immediately what kind of energy your apps are using. And since it's such an amount of information that is coming in, the energy usage when you're using it might be quite high. At the moment I'm not using GameWave, so it's not popping up, but GameWave is actually quite energy intensive. And in that sense, and that kind of goes back to also the machine learning thing, sometimes I think that it's probably best to have algorithms that feel right, but that might be less complex in CPU power, because you will not introduce any latency during the calculations, they will consume less battery, and they will just feel better. And that is ultimately, to me, the point, is does it feel nice? If it doesn't feel nice, then it's really not very useful to build something for gesture control. So I'm done. We still have about 10 minutes left. I'm open to any questions or discussions or whatever you want. Yes, sir? Yes, so the question is, can the leap motion work in a horizontal way? You mean a vertical way? So like this? So yes. So they now have a mode where it can be attached to the VR mount of, and incidentally, it would also work like this because it is tied to the head mount. It's the same thing. Other questions? Yes, sir? Like this. Are you talking about the leap motion controller? So your question is, when your arm is rested, does it work?
Yeah, if there is an object just taking your arm.
Okay, so the question is, if something is taking your arm, does it still work? Actually, it works really well, because it just works with images. And I personally, at home in my office, I've got a chair that provides me with arm rests all the time, and I'm positioned in such a way that it's right in front of me, and I just hold my hands out like this, and I never get tired. I don't never get the gorilla arms, because I've got support underneath my elbows. Yes? Other questions? Yes, sir? Good question. Does it work when you're missing fingers? I don't know. I'm not missing fingers. But it used to work. I guess that now with the skeletal model, they kind of, well, let's try it out. Let's see what happens. Has anyone got a knife? No. No. Well, let's see what it does, right? Yeah. It's deforming me. Yeah. That's quite impressive that it detected my thumb being there. Is someone missing a finger? No, I'm serious. I would be interested to know. Jesus, can't trick it. But so in the previous version, it worked without any problems because they didn't have the skeletal model. And actually, I'd be quite surprised that it wouldn't work, because they spent such an epic time working on this new version that I guess it works.
What
but
happens if you hide half of your hand behind some object?
If you hide, well, let's try it again. Which half? So the question is, what happens when you hide half of your hand? Nothing. So it's not saying, well, it gives me a pinky. So it works with, yeah. So that actually might feel nice, right? Because you get an extra pinky. And now this, yeah, and now you get an extra thumb. So I guess it fills out the blanks, right? Which is nice. So now, if you think about this, it's kind of thought process. If you tie that back into VR, people might actually, that are missing fingers, they might actually have a great time because all of a sudden they see stuff that they haven't seen for a while, right? There was someone explaining to me a use case for the leap motion controller also, where they mounted it to a VR head mount for anorexia patients. And so what they did was that they let them pick the ideal representation of a person. So what is like the medium weight of someone, which was usually, well, almost all the time, much thicker than they were because they were anorexia patients, but they thought that it resembled them, right? Which is their self-image has a problem usually. So what they then did was in VR, they projected the image of the person together with the model and then let them touch themselves, and they could see that physically they would go through the actual model that they thought that they were, but then they touched their own body, and they could feel that there was actually a physical distance. And that seemed to have a huge impact in helping them to realize the difference. That it's not just visual, but also could feel that difference. Yes, someone had another question here. Yes, sir.
Has anybody already tried to use it with cardboard?
Has anyone tried to use it with cardboard? No, I don't know. I don't know of anyone. You mean the Google VR app? I don't know. You could be the first one. Yeah. Well, I actually just took one from the Google booth, so I'll probably try it. It's a good idea. Yes, sir?
For the Myo, is it possible to obtain the raw sensor data?
So the question is it possible to get the raw sensor data from the Myo? No. Quick answer. And honestly, you probably don't want to. Because I've got another kind of thing in my bag over there which senses brain waves. It's also EG. It's horrible. I'm kind of surprised that they're even able to make out 5 distinct poses with the amount of noise that you get in there. And that's what they say. They say it's so difficult to find any meaningful correlation in between these streams that, yeah, maybe for research purposes they say that they might open it up in the future, but at this time, not yet. Yes, sir?
It was about the same. If you want to do it on an embedded device or things like that, there's no open source drivers, so you don't have raw data, so you cannot use it.
Yeah, so the question is how to use it on embedded devices because there is no raw data and there is no open source driver. The thing though is, now for the Leap motion controller, there's probably no embedded device that is able to handle the data that is coming from there. It will just drown it. Yeah, you're right, they should open source it. Okay, some other questions? Yes?
Use the broadcasting in the form of JSON or something like that to the embedded device?
So the question is, could you use some broadcasting in forms of JSON to the embedded device? Yes, some people are doing that. So before there was, it's another use case, but it's a similar answer. The Mac driver was not ready, and there was a Windows one. So people were actually broadcasting the Windows information from a virtual machine over JSON, and then consume that from a Mac. But then you need to have another device, which kind of defeats the purpose of having an embedded device. But yeah, so you could do that, but it's your architectural decision.
Still so fast?
Well, depends on the question. Is it still so fast? Depends about your connections, I guess. Right? Some other questions? Yes?
How many mice did you kill to the talk?
Sorry?
How many mice did you kill to the talk? This is the dead of mouse. You killed a lot of people.
How many mice? This is NDA. Let's come over now. Let you sign. No, I didn't kill those 2 mice though in the Hitchhiker Guide of the Galaxy because they built the Earth, right? So I let those live. Yes, sir?
The first time you put on your the Myo, I have a question regarding the Myo. The first time you put on the armband on the right arm and you calibrated, and when you took it off, when you put on the left arm, do you have to perform collaboration again?
So the question is, the sync gesture that I performed when I put on the Myo, do you have to redo it when you put it on the other arm? It's actually worse. So you have to do it for each position. So you will do it here, and if you do that, you will have to redo it. So, but it keeps in place very well, so you will probably not move it around. But each time you shift position, you'll have to, and it will detect it, so it will vibrate twice. I don't notice it, but it will vibrate twice, and then it will say, okay, if your app is written with that in mind, you will see, okay, you have to re-perform the sync gesture and do that. So, yes, sir, in the back. Are you talking about the Myo? No. So the question is there any software running on the Leap Motion? No. So that's why it's so cheap. And that's also why it will not work with an embedded device, because you just don't have the CPU power. It needs probably at least a real core dual core machine so that it can offload that processing to one part and still do all the rest. Yes? If that's it, thanks a lot and have a great rest of the conference.